The next test we're going to perform is a starter current draw test. Now to do this, the best way is to have a clamp type ammeter. If you're still using a shunt and hardwire connections to take amperage measurements, you're wasting a huge amount of time and you're at risk of really doing damage to electrical equipment. Now this is the same Blue Sea meter that I used earlier to do a straight current test. I want to point out a few features on the amp clamp. One is that the orientation of the clamp on the wire that you're going to clip over is important. This particular clamp is nicely designed because it's got the plus side, a current flow arrow, and a negative sign embossed right on the clamp jaws. So this will tell you whether or not you're clipped on the wire in the correct direction of current flow. So what we're going to do for photographic purposes is actually clip it backwards. The reason being, I want you to see the face of the meter. You won't damage the meter, but it will show up on screen as a negative current flow. If it were oriented correctly, the screen would go blank and then it would just give you the numerical readout. We have to be able to do that here so that you can see the screen while we're cranking the engine. Now, what are we testing when we test starter current draw? We're really trying to determine, one, if there's a problem with the starter motor, two, if there's a problem with the wiring going to the motor. And the only way to really be sure if there's a problem is to establish a benchmark early on. You need to know what is normal for the given engine battery combination that you're working with. Now this happens to be a very new boat. We know that everything's functioning perfectly. So what we're going to do is establish the benchmark value. A boat owner would be wise to write that number down so they know what good is, and then any variation from that benchmark number may indicate either an electrical problem with the wiring or a problem with the starter motor itself. One more thing relative to starter current draw. You could have an engine problem. Again, you need to make sure that the engine is turning over freely, doesn't have water in the cylinders, anything really catastrophic like that. This would usually show up or manifest itself in many other ways. But let's see how we're set here, and we'll establish our benchmark, and then we can talk about the results of our finding a little bit more in a minute. On this particular boat, the starter motor is somewhat difficult to get to. However, the cable feeds, both positive and negative, that go to the engine are really accessible. We can see here a red and a yellow. By the way, the yellow is the DC negative, which is one of two choices under the ABYC standards. Yellow being the preferred choice on modern boats versus black, which was the traditional color. This helps us to differentiate between AC line voltage or AC wires cabling, which would be black for the hot wire, and the relatively inert DC negative. I've removed the split loom covering from these two cables so that I could, one, show you the color, two, more easily get my amp clamp around. Now these two cables come directly from the starter battery, and the positive goes directly to the starter motor. So I'm going to clip the clamp, and again, I'm going to remind you, I have to hook it up backwards for photographic purposes here. And we see that we've got, a little microamp reading. I'll zero my meter. And what we have to do now is activate the starter motor without actually having the engine start. And keep a careful eye on your meter to see what your peak starter current draw is. So, at this point, I'm going to have my assistant crank the engine over from up above, and we're going to see if we can get a baseline for our starter current draw.
All clear.
Okay. Okay. The peak reading that I saw was 129 amps. which on a small sailboat auxiliary engine, a modern engine like this, is pretty much normal. When you get into diesels, mid-sized, larger engines, it's not at all uncommon to see amperage readings that are going to approach 1,000 amps. You need to have an amp clamp that can read that high. This particular clamp is new to me. I don't know what its upper threshold is, but it certainly had no problem with the 129 amps. I would guess that this particular meter is probably rated for a max reading of around 200 amps. It's going to work fine for a boat like this. So what I would do next is write that 129 amps down somewhere in the boat's log, and I know what normal is. Now, what would be abnormal? Interestingly enough, we'd be looking for a number lower than 129 amps. If the circuit cannot draw the current that it needs, and we've already tested the batteries and found them to be in good order, then that tells me there's a wiring problem between the batteries and the starter motor. Probably a loose or corroded connection. Or, if there was evidence that one of the cables had been replaced, maybe the cable's smaller than it should be. If it's pulling more amperage than it should, that generally indicates that the problem is inside the starter motor, and that assumes that you've already determined that you don't have an internal problem with the engine. So the next step, if it were a higher than normal reading, would be to remove the starter and send it out for overhaul or get a factory rebuilt unit. More common would be a lower than normal reading, which would indicate a bad connection that simply restricts amperage current flow in the electrical circuit.